We will continue with our topic on coastal protection. Coastal inlets is defined as a short, narrow waterway which connects the interior water to the sea, and it can be either natural or man-made. In this figure, we see example of a coastal inlet over here. Due to a longshore transport, typically bar formation may be observed in the seaward direction as well as the interior of the coastal inlet. As a result of that, the section may become shallow over time and thus impede or basically makes navigation becomes much more difficult. This is the reason why where the inlet is important for navigation, then a pair of jetties may be constructed here. The jetties will be able to intercept the longshore transport so that the sediment does not block the inlet. Besides that, the jetties also allow any upstream discharge to be able to flush out through the coastal inlet such that it is able to maintain sufficient depth along this narrow waterway. Since the jetties interrupt the longshore transport, it may result in long-term accretion on the updrift side and long-term erosion on the downdrift side, which is undesirable. As a result of that, a solution for sediment bypassing must be provided, in which the idea is to transfer the sand from the updrift side to the downstream side so that it maintain or restore the natural sand bypassing without going into the waterway in the coastal inlet. This can be achieved typically by dredging and pumping, whether it is a permanent dredger onshore or a floating dredger in the sea. Other options include excavation and transportation by truck. Essentially, sediment bypassing is to address the issue of down-coast erosion and unwanted up-coast sediment deposition. Typically, this may be carried out periodically in order to maintain the sediment balance of the area. The bottom line is to achieve the lowest cost per meter of nourished beach per year over the project lifetime. Sand which is removed by dredging is typically transported by pipeline or floating barge or trucks, and the cost typically increase with distance as well as the depth of the dredging, as well as operational downtime during high wave or storm event. This figure here shows different types of dredgers which can be used, including mechanical type as well as hydraulic type. This is a case study of sediment bypassing at a coastal inlet in River Tweed, Australia. You can click the button to access the website and watch the video. Basically, the location of the Tweed sand bypassing is here, which is on the west coast of Australia, south of Gold Coast. This is the river and this is the waterway and the inlet. The natural lateral drift is such that the sediment will move in the northward direction, and so in this case the sediments are intercepted here at the jetties and they are being pumped to the down coast section and deposited in this region so that the sediment are able to reach its downdrift section without passing through this waterway. This is a close-up view of the sediment bypassing system. A sand collection jetty is constructed here to pump and suck the sediment across the river to the downstream direction where the sediment may be released. These are further detail on the project. This is the sand suction trap which carries the sediment upwards and then pump into the pipeline system so that the collection jetty is able to send the sediment onshore and subsequently to its destination. This figure shows the inlet and the excessive accretion previously when there is no sediment bypassing. With the sediment bypassing, right now the coastline here is clear of sediment accretion. These are other views of the project. The pump sediment are being screened here. This is how they are discharged on the downstream side. This is the sediment collection jetty. This is the waterway and the pair of jetties. This is the dredger to perform additional dredging if required. This is another view. This is the sediment collection jetty. This is the pair of inlet jetties. And this is the downstream beach, which is continue to receive sediment supply from the upstream here via the sediment bypassing system.